So now for today's session, this is one thing that I wish that books had a little bit of extra emphasis on, mostly because books do put a lot of effort and time into describing what is a string, what a string happens to be underlying and stuff like that, because it's a very important data structure. I mean, it's a very important object. It's not a data structure. It's a very important object type. So why do we do it for a string, but we don't do it for other data types? And I don't have a good answer, but I decided that in Java 1, I am going to dedicate a full session to an object that is probably the most human object of all. And why do I think that? I mean, yeah, sure, humans invented language and whatnot, but language is not as universal. Like a specific language and a specific text is not as universal as for example, the understanding of date and time, which, you know, measurements. Let's talk about measurements. For example, the United States uses non-metric system, which is the imperial inches, yada, 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 feet, or even for weight in ounces or pounds. Whereas some other parts of the world utilize the metric system, you know, centimeters, millimeters, grams, kilograms, etc. So one thing that I think that it's pretty much universal is the understanding of time. Now, that doesn't mean that people all, like everybody treats time equally. And, you know, there are cultures that are very much strict about time. There are some other cultures that are much more relaxed about time. But all of them operate under the same scale, which is 1 minute equals 60 seconds. 1 hour equals 60 minutes, 24 hours in a day. And essentially like the Gregorian calendar, which is what we operate. Of course, you know, there are cultures that have different types of calendars, but in general, the understanding of 1 hour is the same across the world. But why do I say that it's also very human? Because we use time to describe things beyond date and times. For example, how long does it take, or how long is downtown LA? That question, most people, at the very least in Los Angeles, would answer, downtown LA is about 30 minutes from here. As opposed to answering in a distance. You know, like we're using time to describe distance. At the same time, time is relative. Example, in 2 weeks. When I say in 2 weeks, today, it means a very different date than me saying in 2 weeks, say referencing 2 weeks from then. So time is relative also in that area. On another area that time is relative is formatting. For example, there is, you know, this format about, you know, January 26th, and 01, we could do like something 01, 26, 21, or we can even say Jan 26, 2021. All of these are different strings that represent the same spot of time. Not only that, when I say 3:50 p.m., is also going to be relative to where you are. Because 3:50 p.m. to me means 6:50 p.m. to the East Coast. And you'll see later that sometimes, relatively speaking, you might have a big gap in who is considering time zones and daylight savings. So date and times are very, very human data types. And I don't know if there's anybody that disagrees. I'm opening the floor to you guys if anybody disagrees with this statement. Nobody? All right, so then let's get started. We're gonna talk about date and time basics today. It's a simple class. We're gonna do lots of hands-on stuff, which I think a lot of you will appreciate because we need more hands-on. We're gonna be learning how to parse dates. We're gonna learn operations on a date and just exercises for the class. So to get started, we need to go back to 2 classes ago. And 2 classes ago, we said that computers understood numbers. Well, let's simplify it. Numbers, binary, text. And by saying that computers understand, I mean like are able to write and read. That doesn't mean that they're able to rationalize it. And yes or no. You guys recall these, right? Like from the very, very, very basic ingredients that, essentially from our primitive perspective, this is float or double, int or long or short. And the rest is just, very straightforward. So if we part from that, the fact that a computer understands or is able to read and that data, I would like to do a little bit of an exercise and have you guys think, how could we represent time using this? Who could tell me something?
I guess you can just have like, for maybe text, you can just write like the months.
Okay, that's one option.
Or you can just do, you can have numbers, you can have, you just have numbers.
How would you use the numbers?
Like, yeah.
You could, I don't know, you could designate, I don't know if this is right, but you could designate every integer as a month and the float as sort of a decimal fraction of how far you've progressed in that month.
Okay.
Repeat that again, Josh.
You could use every full month as an integer, and let's say, for instance, that we're talking about April, which has got 30 days in it, right? Yeah. You could, if you're on the 10th day of that month, you could make it a 0.33. So it would be basically your full 3, which is March. So you're in March, or actually technically 2, right? Because you've gone full through 2 months, and a 0.33. Yeah, it would be 2. and a 0.33 tells you you're 10 days into March, basically with 1 and 2 representing the 2 months that have passed.
That is very interesting, because what you are saying is that you set up a baseline of when you're going to start counting time, and then a representation of how to represent time from that baseline.
Mhm.
Okay. That's that, just to clearly understand, that's what you're saying, right?
Yeah. That's,
Okay.
yeah. You're setting up the rules and then, using the integer and the float to correspond to those rules as far as how deep into those time constructs you are.
Josh, you're absolutely right of how it is done internally, because computer scientists decided that the baseline was going to be January 1st, 1970, GMT. And then the representation is an int count of milliseconds since the baseline. So basically, the computer is doing what Josh just said, but internally it's actually just storing every single millisecond that has happened since January 1st of 1970. Why January 1st, 1970? It's known as the date when Unix was born. So it was just grabbed as what it's known as Unix epoch time. And that Unix epoch time is obviously 0. But if you guys remember from our primitives, we have scales that go from 0 to, if it was a long, we have to 9 quintillion to minus 9 quintillion, right? Because it's a signed operation. So because our range of numbers that we can choose goes from 0 to 9 quintillion, we have enough milliseconds to say, how would it be? It would be to 2 to the 64. That's basically those. Oh no, wait, do we have, was it 32? Or let me just see one thing. Where's Keynote? By us going back to Java class 2. Yeah, along it's 8 bytes, so it's 2 to the 8th. So 2 to the 8 equals, let's just say, how many milliseconds can it actually hold? Two. No, this is. Oh, it's bytes. It's bytes, so it's even. Let's even actually ask Google the question. Max number of milliseconds. Number of. The maximum value. No, that was not it. What I'm trying to find out is how many milliseconds in 1 second. What I'm trying to find out is how much data can we fit, but that's irrelevant. That's just me being curious right now. But the thing is that we have a certain amount of positives. So, 2021 is somewhere around here, just to say something. And anything that happens before what's it called? January 1st, 1970, which is this 0, then it is a negative number. Now, if we take that at face value, first of all, internally, the computer actually can do interesting stuff. For example, with that in mind, you could actually perform comparisons to know if say January of 1969 happened before January of 1970. Because if it's numbers, you can just do a subtraction of those two numbers and find out which one has happened before. So it allows also comparisons to be done really quick because you're only dealing with numbers. But to us, to Brandon, Josh, George, Sareth, everybody, to me as well, we don't think in those numbers. We just think in the dates. So because we are holding a number, I'm going to put it in, it's a long, because it's a long, we are going to wrap that long in an object that has, just like strings, convenience functions, and then we can encode and decode that long into something that is understandable. Understandable, not understandable. There you go. So this is where the object date came from. And that was how the creators of Java decided to start implementing that, the basic date stuff. So knowing that, I guess to summarize, we have an object called date, and that object has a long inside of it and a bunch of convenience functions to help us navigate that object. How does that translate into code? Let's start, a new file called class 4. And we're going to do our main function. Then we're going to use the date object. We're going to get it in red because we need to import the package. And we select the one from Java util date. And if we create any new object that we create, it's created by using the keyword new. And then we have the name of the object, which matches the class, and a constructor. We're going to see these things next class at a further detail. For now, just understand that this is the way that we're creating an object. If I were to print out this date object, because it was created with a default value, I'm going to get today's date. And right now at this time, so it's 7:25 at second 32. If I run it again, it's obviously going to have a higher count, second 42, and so on. So that's the easiest way to create an object. Let me give you a minute to let you guys copy it.
I'm sorry, what did you click on when that date keyword showed up red?
Oh, yes, that's a great question. I'm going to delete this guy. And what you do, you put your cursor on top, and then you hit the Alt key and enter. Oh, or you can right click on it sorry, it's not Alt Enter. It's command. In Mac is Option Enter. I think on PC is Control. I think.
On PC, it's
Alt.
yeah, it's Alt on PC.
Yeah. So on a PC, then it's Alt, and then you hit Enter, and you're gonna get different types of imports, and that's when you get it, and this line appears at the top. Let me reset it and give you the full minute. Okay, who needs a little bit of extra time just to make sure? Don't be shy. If you need time, just. So we created a date with just creating that object. But then what would happen if we did d.getTime? Essentially, when we do d.getTime, we are accessing the long that is being stored by the object. So we know that when I don't use a constructor, like right now, I get the new date, and then d.getTime gets the unit of time. You know, this is right. This means right now, and this will say, okay, well, what is the timestamp for right now? So you can see that this is that timestamp. Now, what would happen if I put in such number with an L at the very end, so it's a long, and then decided to print it? I am creating a new date from that timestamp, and now I will create an object that will translate to 7:29 with 22 seconds. This is going to change soon, but you know, if I run it again, it's not essentially doing the same date time, because I am saying, okay, use this date with this time. Let's even change one of these to zeros, and let's see what date do we get. January 17 to 2021. So this guy essentially is the one that dictates the amount of time. So if we then did, you know, 0 like this, essentially, see, we're going back to 2022. If we replace this guy to 0, you can see now by removing those that I am in May 6, 1970. If I were to pass 0L, because it's along what it needs, we would get December 31st at 4 p.m. Why December 3rd from 1969? Why that time when it's a 0? Can anybody tell me? Let me even bring the slide to the front so that way you guys get to see. If you see.
What else? Is it because the 0 actually is for GMT or PST?
Exactly. If the difference between GMT and PST is essentially the 8 hours that this is highlighting that are needed for January 1st, 1970, and this is PST. If we have 0 on GMT, it would be January 1st, 1970. And if we did, you know, the same number that we had before, but negative, we're getting December 15, 1918. And, you know, if we go, you know, the further we go, we're getting 1655. So, you know, let's see how many. 1938. Let me just. I guess what I was trying to get to earlier. See, this is February 26 from 1200. So let's see how much I can get it to. Ooh, this time I exceeded it. Let's see. I think I went overboard. Let's see. $1,200. Let's add one more 9. I'm just trying to get like what is the maximum? What is the range on that scale that we were drawing here? Okay, so it's definitely not that. Let's see. Ooh. Well, so I guess you know there's a limit in the Java aspect. We'll try to get to you know the year 0, but this is you know going into the 1200s, and then on the other direction, we're going to the year 5138 by just making it, you know, so we have enough range with longs. I guess it is due for a time of asking what are your numbers with regards to understanding the date object and the fact that Java utilizes an int to store and calculate time.
One.
Yeah.
I think I remember like watching a video, or I think watching a video about it where there's like an issue with this, like they ran out of space or something about like affecting all computers with this epoch kind of problem.
Oh, I think
know.
the concern was the famous, I don't know if you've ever heard this combination of letters. And this is, if you haven't, then you probably never used a cassette tape or you know, or an Atari or something like that. But these 3 letters was the year 2000 problem. And the idea was
Oh yeah.
that in the year 2000, it was a flawed theory though, because it was like, well, it was a potential because people were representing dates like that, where you had,
Oh,
you know, month, day, year. The moment that 00 would happen, would it mean 1900? Would it mean
Or
2000, or actually the year 0? So that ambiguity could have caused a lot of problems. Not only that, if you had systems that were representing dates, and that is, if they were representing dates as strings,
string. Okay, yeah.
then you would have that problem because you would you know not really reset it. But if you had a system that
Times.
was actually storing it as a string, then you'd be in big trouble.
Okay.
But that was in the year 2000, and there were like all sorts of bugs to apply patches and things that. Yeah, it was like COVID. Yes, I'm with you on that. It's you know, like I said, if you never heard of the Y2K words, probably you never played with cassette tapes or you know you were born with the internet, I guess, which my generation had. Half of my life I've had internet, half I hadn't because it was not invented. Is it an accurate statement? Sort of, yes. Anyway, okay, so we know that if we don't pass a date, we have a number. I mean, we have today's date. Otherwise, if we pass a number, we would have a date. Okay, great. Now we know how to make dates. Sure. Now let's go into the Java API for dates. And when we go there, we're going to notice one thing, and this is, version 8. And we're going to start noticing all these deprecated. For example, technically, I could have done a string, where if I was creating that, I could have just created a string. Actually, let's do a string by using month, date, year, month, date, hours, minutes, and seconds. So if we were doing year 2020, month, let's do 2021 01 hours would be 00, let's say midnight, 00 for minutes, and 00 for seconds. And you see date, month, date, hours, minutes, seconds. One thing I want to clarify with IntelliJ that actually we encountered that a little bit faster than what I thought. Another thing that happens with IntelliJ is that you're going to see this line and you're going to be inclined as you are working on it to copy it as date, year, colon 2021, month, colon 01, date 01, etc. And you're going to get a lot of these red things because those red, the year, month, date does not exist on the code. This is just labels that essentially were defined in the underlying functions so that you know visually what you are passing. I know that for year I'm passing 2021. If I had it this way, it would be pretty evident that I'm doing something wrong. But unfortunately, this is visually just something that IntelliJ adds to the top of your code. If I were to go here and then put it in a text file, let me open up a text editor. So, okay, if I were to create a new file, and I would just copy that, you would see that this is the actual underlying code. Then where is those year, month, date, and hours coming from? Like I said, the underlying function that you're calling, and if I alt click on the function definition, you'll see that it was expecting a year, month, date, hours, minutes, and seconds to received. That's where those numbers are, those names are being passed. But again, they're not part of the code, these labels. Sounds good? Okay. So, okay, I can create a date like this. And theoretically, I should get 2021. First of all, why is it February when I'm saying the month is 01? Well, turns out that month is it's a rare thing where months are counted from 00 if you want January. Regardless, it's doing the wrong thing because it's still doing like the year 2000, 3921, even though that I'm passing that directly. There's a reason for that. This was deprecated before the year 2000. So it's not maintained and it's actually not advised to being used. You can see why it's scratched in here. And so then the question begs, okay, I want to be able to pass, or at the very least, modify my data object so I can set the value of what I want. Okay, let me start exploring the API, blah, blah, blah. Oh, get date, get hours, get minutes, get month. Okay, set date, set hours, set minutes, and all of these guys are scratched. You can notice that. That means that IntelliJ, I mean, not IntelliJ, that the code is actually deprecated. That means that it's not supported anymore. Then you're probably wondering, why are you teaching us something that it's deprecated, that it's obsolete? The reason is because a lot of things on the date class are deprecated, but the date class itself, it's not. The date class is used constantly as a bridge between different other classes that have a similar underlying data. So if we wanted to just then maybe create our own, if we wanted to create our own date, there are a few options. We can use date format. Is it date formatter? Let me just double check here. Simple date format. Oh no, I can actually use that one. Yeah. We can use a date formatter, and I'm gonna call it DF. And this is just, here, I can provide a language, or using a little bit of a language. How am I going to format my string so that I can convert it into a date? So for example, and let me just close again. Okay, so simple date format allows us to specify a string, how we want to format it, and how we're going to get a date from given that formatted string. For example, if I put, and this slide here is relevant because I am describing how I am going to format it in order for me to get something. So for example, we were talking earlier about us having dates being formatted like this. So let's set up a string formatter for this. So we're gonna do, it's 4 digits for year. So we're gonna do YYYY dash, because we're using a dash, dash DD, 2 digits for date. And now let's just double check that I'm in sometimes I just need to use uppercase because little m means minute. So in here, I'm gonna change it to uppercase M because that is for month. And then we know that D is day of month. So we're gonna create a thing that it's gonna extract a date object from an actual string. So if we did 2021 01 01 and we did date D, you're gonna get this error. Right now it's a chicken and an egg situation. What I would like you to do is to put your Alt Enter, your Alt Enter thing, and you can select one of the 2 ways. I would select the first one, add exception to the method signature, just to disrupt it the least. It adds this code, which right now we're gonna ignore. And now, technically, we can have that string extracted from an actual, from that date extracted from that string. You can see January 1st of 2020, 0 minutes, 0 seconds, 00. Okay, let me give you a few minutes to catch up with this. Let's give 5 minutes here on the clock.
What?
Yeah.
Can you explain again why the formal way to define the day is not working? Do you put the 2021 and then the result says 3921?
Yeah, because it's deprecated. That function, it was deprecated. It is not supported anymore. So post year 2000, they're not even maintaining. When something is deprecated, it's used at your own risk. Eventually, we're going to pull this function out of the language. But if you get weird results, don't blame us. Don't even put a ticket. That's basically what they're telling you. So far, we've learned that dates are represented by numbers starting from January 1st, 1970. That's the internal value. That they are represented by a date object. We've understood that Java decided to deprecate a bunch of the functions in the date object, and I'm going to show you why it was done in the next part. But also, I just gave you an alternative way of creating any date object from an actual string given that language. So I would like to probably do maybe a few minutes to give you the chance to research how do I get this to give me the code that would get that date in that format, November 21st, 2005. So I would like you guys to play with the settings of simple date format to try to get that date. Okay, let's start and let's see who can get it in 5 minutes.
I was able to get it to like November 21st, but then it also like printed the time even though I didn't specify it.
Yeah, the time is going to be printed. Doesn't matter. Because once it converts into a date, the date will have date and time. So you can actually specify minutes, seconds, etc. That's why in the slide, I even including like AM, PM, hour of day, hour of time, minute, hour, second, etc., etc.
Also, like I did 3 capital M's to try to get the month, I guess, abbreviated, but then it also printed the day.
You want to present so that way we get to share to see?
Oh, okay. Yeah, like I tried to do 3 M's and then the date, and this is what I'm getting here. It's kind of weird. Like the years at the end here.
Yeah, so the year is correct. No, you're correct. Yeah, you're right. You got it right.
Oh, but
You got it absolutely right. The thing is, like the date object is going to format. You know, you're getting Monday, November 21st. You're getting Monday, November 26th. That means that it did convert from that string into an actual date object with specific time.
Okay. Okay. Oh, okay.
Yeah.
I didn't know if you just didn't want the Monday or.
No, that works. Okay. Did anybody else was able to get this?
I got that, but I thought it was wrong at first too.
Okay, but you got it the same way.
Yeah, it looks the same.
Okay.
Anybody else?
Juan, what about the comma? Like, how do we do something like that? It doesn't really seem like it's putting it in that format. Because I know if you do like the dashes, it'll probably do that. But
Yeah, no, you're specifying the format of how you're going to pass the string. So if you put the dashes,
yeah,
then
I put that. If I do that, yeah, if I do that. Oh, well,
yeah, there you go. You are specifying the format.
okay. So it's like you don't even need this, right? You don't really.
No, if you remove that and run it like that, it's just all depending on, yeah, and then it'll crash.
Oh, I see. Just like how you pass it.
It's exactly, yeah, you're essentially, yeah,
okay,
you're essentially specifying how you're going to write that.
got it.
Okay, but we can't make it like print out a comma, or would we have to like?
Yeah.
No, that we would have to format it. And that's actually what you can do on the way out, because right now what you're printing is a date object. If you want to format a string on the way out, then you could actually do, there's a df dot, do type df dot, let's see what, format.
This one here. This one.
Yeah.
Yeah. And then put that one in between the printf, the println. So put that statement in between the parentheses instead of the D in, yeah. And now run it. Now you're formatting the string to the format that you're saying that the string is going to be. So it's going to look like your string. So no, you do not need that. Oh no, df dot format D. Yes, sorry, you do need that. Yes. Okay.
Oh, there we go. Okay.
So you took it from string to date to string.
String to date to string. Okay, got it.
Yeah.
So if I wanted to put a comma here, would that work? Well, no, that wouldn't work because
You could, yeah, you need to import it.
I mean, you
that needs
could,
to match that, right?
Yeah, or you can create a second formatter if you're trying to reformat from one format to a different format.
Oh, okay. Can I? Okay, so maybe if I do like
df2 or something equals.
There we go.
Well, let's just do an exercise. Copy line 8, duplicate it, and rename it to df2. And then let's change the format with dashes now instead of comma. And then in line 14, we're going to use df2. No, you don't need to do that.
oh yeah. Yeah.
df2. No. Format D. There you go. So you're going to reformat that string to with the spaces and the comma.
Okay.
Okay, now run it. And it's going from format 1, which is from df1, to format 2, which is df2. Because you're specifying a different formatter for the output.
Gotcha. Okay.
okay.
All right. Let's get some numbers about this string formatter thing. Now that we did this little exercise. Now we understand, again, just to repeat, the date is basically just a number of milliseconds that have happened since January 1970. For the positive side, for the negative side, obviously, it's anything that it's after, before 1970. Then what is going on in here is we know that the date class was essentially deprecated, all but the creation of the date object, rendering it just as a representation of a date from, the actual moment that it's done. Why was that? Well, you're going to realize a lot of things with Java. Java was early 90s, it was created, and as it was evolving as a language, and as it was being the internet more a global thing, Java started having challenges that other languages would not have because because of the internet. Like, honestly, Java was the first internet ready language. It was not really internet ready. It was a trailblazer for the internet. So when you think about, the writers of the language, initially they started with something that was ASCII. ASCII is just essentially, it stands for it represents the American character system, which essentially represents, letters, normal letters. Oh, what am I using? Normal letters like A, B, C, D, blah, 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 blah. And, lowercase a, B, C, D, blah, 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 1 through 10, and so on. But then, ASCII, we started realizing that others had other characters that didn't necessarily have to do anything with really the English language. So ASCII became obsolete. I think it stands for American Standards of Character something. I don't remember exactly the full thing. So the first attempt to replace it with something that not only has Western characters, but characters that, I don't know, like, for example, Chinese or Korean or Russian that are non-Western characters, they needed to be supported as well. And now, we have, so they created another standard that it's known as UTF, which is Universal Text Format. And depending if it's 8 or 32 bits, there's plenty of room. But even if it's a UTF-8, there is this thing actually, where this thing actually is able to, is there a text thing here? No, there's no text. There's no text tool in this one. But actually I can show you here. Actually, I can show some of the UTF characters. Come on. Emojis is also part of the UTF characters. So emojis, as simple and as silly as they look, they are treated like another character language, such as, like if it was Russian, Chinese, Japanese, Korean, Arabic, yada, yada, yada. So the emoji is just part of UTF-8. So, computer scientists started realizing that not everything was revolving around the United States, so they needed to expand it for the rest of the world to use it. Second thing that also happened, and this is related to dates, is that it turns out that, before, if you had a computer, you didn't really need to think about the world, because most likely you were only going to have only a subset of computers. UCLA as a university was not going to have multiple campuses in different states or in different time zones. It was just going to be in their computer labs would be in Los Angeles, and so on. So time zones became less of a priority at the very beginning of the internet. It's not like it was unknown, but it was just lower of a priority to fix. And then once the internet started happening, then it became a situation. So for a first pass, it was fine to use just the date object, but it turned out that it was not the right tool. So they re-engineered a bunch of the tools to be able to display the data correctly, to display the data and manipulate the data in the best way possible. So, the tool for being able to perform operations, and I'm going to maybe do a little bit of a better example here. The tool that was used for this, where do I have my, come on, let me move it here, one sec. Oh, well, let me just disable all so that we don't have distractions. The tool for us to perform operations in a calendar, in a date, it was a calendar object, which is essentially the same as this traditional calendar where you click on a date and you have events for a particular date. So the representation of the calendar object is, if we want to see it all the way down to the level to this, this, let's put it as squares. Date. And then inside we have our long. Essentially, the calendar object wraps a date in the same way that the date wraps a number. Which one is the date that is selected? Well, basically, if we want to see it visually, is the one that we have on the circle. That is the date object being represented. And then obviously, if you have an event here, let's say that this is our event. I have parents of my kids' former soccer team subscribe, so I got to delete that before they get a notification of something. But the date and event, it just essentially is similar representation where whatever date and time that you have selected, that is essentially the object that you are representing. Does that analogy like click or well, not click, but the word that I'm using is, does that analogy connect with what your guys' understanding is? If so, then let's get some numbers. That way I know if I am explaining myself okay. So if we want to create a calendar, we use the calendar C equals calendar dot get instance. This is the way that we're going to get a calendar instance. And then we can do C dot set time. This is one thing that I wish that the Java developers would have used a different word, because you're not setting the time, you're setting a date object. So by doing this, and let's put a date that, 2001, just so that it's something more obvious. So I can do now C system C dot get time. It's going to yield, when I do get time, it's going to go from the calendar to the date. And if I run it, you're going to see that now I'm setting that calendar to be for January 1st of 2001. If I did another dot get time, what would happen? C dot get time dot get time. Let's have a guess.
So if you do get time, that's taking a date object, right?
Here. And then if I do get time again, what would I get? Okay, so if this guy is returning a date, and we know that a date dot get time yields what?
Well, whatever it's wrapping. Is that?
Yeah, so from
number
calendar dot get time gives us a date, and
Mm.
then if we do get time, it gives us the long.
The long.
So
Okay.
now if we go up, because we're effectively applying that get time to a date object that these returned.
Got it. Okay.
And how do I know that? How do I know that? By me going into the API, and I'm going to put Java API calendar. And then when I go into that, get time, you're going to see here that it get time returns the date. Now, if I do get time in million, it goes directly, it's a shortcut for that. So, so far so good, right? The importance then of this class is that we can perform then all sorts of operations. Oh, sorry, set time. And then we can do C dot set. Well, we can perform like even, rarely we think like, oh, if I ask you, what is next Monday's date? Likely none of you are gonna know without looking at a calendar, because technology has made it really easy for us to look. And besides, we always think next week, next month, a week ago, we are always in a reference time situation. So if we do like add, and we specify what field and by how much, so we can do calendar.week, comma 1. If we're next week, and I'm going to delete one of these get time, I'm just going to go directly. You can see that the week after of January 1st, 2001 was January 8th, 2001. And by that, you can start, or you can then also do C.set And then we can do calendar dot whatever field that we want. All these uppercase ones are the calendar. So let's say that we want to be the month. So we're gonna select the month, comma, and we're gonna say that it's gonna be October. So essentially, we're gonna do the 1 week after the 1st of October of 2001. I don't know why my machine's so slow, but yeah, so November, oh, yeah, I forgot. Month is 00, the first month. So in this case, by putting the month 10, we're going to November. So November 8th of 2001. So calendar allows us to do that type of adjustments to the dates, essentially in the same way that we are doing. Oh, here it is. The same way that we can, essentially go to the week after by just selecting the week after, like, or something like that, or we can change the date completely. Okay, so let's get some feedback on understanding the calendar.
So when we use the calendar, we can move forward a week or backward a week. But is there any way we can just use the day and also do the same? Adding the
Yeah, you can change the date, like everything on the calendar object. On the calendar object, let me just make sure that my IntelliJ comes back up because, okay, here it is. In the calendar object, let me just see what the hell is making kernel task. What do I have that it's making everything Windows server? I have, oh, Zoom. Zoom is making everything slow. Okay, well, yeah, by using the set function, we can set any field of the calendar to, like we want to say like, year, we want to say that the year is 2022. We can do it that way. It's just really simple operations into the calendar object.
Yeah,
So,
I mean, the calendar we use the C add to move forward and backward. But if we like only use the day, not the calendar object, use the day object, that can do the same calculation to move forward.
Oh yeah, like these, for example, yeah, we can add 1 day. Let's say day of month. Yeah, so that's gonna add it. So it's gonna be January 2nd. Well, November 2nd, 2022. November 2nd, 2022. So yeah, these fields are important enough to like be able to change it. Like you're essentially telling it, what do I want to manipulate and by how much?
Juan, is the calendar class, is that like inheriting from date or something? Like, is that, or what do you mean by it's being wrapped?
Why does it mean to be wrapped? That's an excellent question. And this is something, let me just do.
Or you're just like putting a date object in the calendar class or something?
Yeah. Basically, as a sample, you can put it as a member by saying private long time. That's essentially how this thing essentially like wraps it, so it holds an object, and the calendar is putting like a date like that.
Okay.
Obviously, with the proper imports. That's how things are wrapped. You're essentially like putting it inside of an object and then adding all the functions like public, void.
Yeah.
But all the functions and members and all that, we're gonna see next class where something like that, where we're creating the functions and stuff like that. But we're gonna see all those next class to a greater detail. Okay, doke.
I'm asking that because in Python, if we set the variable to be date and then we want to do the date calculation, we just add 2 or 3. It will automatically add the date, not the millisecond. But right now, it seems like we are doing this kind of like date calculation in the calendar object. Is that correct?
Yes.
Would it be possible that we do the date calculation without the calendar object? Like we just
Yeah, so there's more considerations to that. To a degree, also you got to understand that Java has been evolving since the 90s, and a lot of newer languages like Python have seen what Java has. When something evolves like that, becomes a little bit messier. And newer languages decide to say, okay, we can do this better, and they're going to do a different approach. So in Java, because they couldn't, because the original design of using the date object for what it was used, it was incorrect. They decided, let's just deprecate the majority of it, and let's put objects that would make a little bit better sense.
Okay. Okay.
Yeah, so it's mostly about the evolution of the language.
Nice.
So if we want to do the date calculation, we have to use the calendar object.
Yeah, yeah. For simplification purposes, let's leave it as yes.
Got it. Thank you.
However, then let's talk about other topics. Yeah.
Is it just that like the date object just doesn't have those capabilities? Like it doesn't have like a function
To
Yeah,
add,
they initially had it, and then they deprecated because they wanted to make it less dependent on times on that was a local time zone and things like that. It was flawed from the beginning, that the implementation of that date class.
Okay.
Yeah, so they learned from it, and rather than removing support and then screwing a bunch of users, they decided to create a new object, and then that's what they were going to push. Now, one thing that is important about time, that I actually want to point out, here, this thing about back to milliseconds. Dates, if we want to do something kind of crazy with dates, actually, yeah, for now, I'm going to actually delete all this for now. Let's assume that we are trying to profile something that it's running really slow. Let's assume that let's do for long I equals 0L, I less than let's assume that I'm doing something like this, where my program is just going to run not as fast. You can see that it's running right now, and it's taking forever until it finally finishes executing. Well, for purposes of maybe simplifying it, let me stop the execution and remove a little bit of like that. A few zeros make a big difference. Okay, so that one took a little longer. Let me just add one more so that so you can see that this took a while to run. And once you have a lot of code, you will try to figure out, okay, why is this thing slow? A good way to figuring that out is by putting a date object, let's say pre for the previous time equals new date. And then after our suspected code, then we can do date post or now, for example, new date. And then we can profile by saying that the difference of pre.getTime minus pre.getTime, now.getTime minus pre, we can see how long it took to run. But remember, this is in milliseconds, so it might not really tell us much. It's telling us that it's taking 2,541 milliseconds, which, when it's a number like this, it's fine. We can translate it and say it's 2.5 seconds. But let's assume that if the number was bigger, we can then divide it by 1,000. That entire operation, that entire subtraction, we divided by 1,000, and then we divided by 60 seconds. So now we went from milliseconds to seconds. That's that division of 1,000, and then from seconds to minutes. And because of that, now we know that iteration, because it's a long, let's just put it as a float. And for us to put it as a float, we just put everything divided by 60.0. We can see that our operation took 0.03 seconds, which is, for purposes of this exercise, this is 0.03 minutes. So this is how we can convert, and we can essentially profile if our code is running slow or not, and finding out where are the bottlenecks. Does this part make sense? Let me get some numbers for that. Perfect. Okay, so now that we know that that worked, let's move into a different set of situations, time zones. And time zones, they're complicated because, let me just make sure that this is actually a little bit bigger. Time zones are pretty much arbitrary. You can see how there's a time zone coming up here, and essentially it's hitting Brazil in you know, but it's not being accepted by Brazilians as that time zone. Brazilians and Argentinians have the same time zone, even though that, you know, the majority of Argentina is under this green time zone. Now let's look at another example. China is almost as big as the United States, the territory, and it has only one time zone. So whoever is on this side of China, in the morning, their day is going to be really bright, while this side of China, their morning is going to be really dark, or vice versa, if I'm thinking it correctly. But you understand, one side is going to be really dark, the other one is going to be really bright. So they don't necessarily match whatever their neighbors are pointed at. So time zones are something complicated, and it's not something always that you can say, oh, well, Los Angeles is always at this time. You know, sometimes certain cities and certain places have decided to opt out of daylight savings time, essentially shifting the entire time zones. So that has become a giant mess. Then the question is, how do we switch from time zones? So we're going to do a little exercise here. First of all, there's this thing called instance, which is very similar to dates. But now let's say, like, now we're going to try to figure out to instant. Now we have an instant, and that instant that instant is essentially a timeless, you know, now. And let's even print in another line, new date. We're going to see how the different formatting actually has affected that instance. So that way we understand the differences. See, this one is essentially formatted to GMT. The other one is local. So whenever we convert to instance, Java is essentially removing the time zone and giving us a timestamp that is to the Greenwich Meridian time. Does everybody know what it's, let me just ask, does anybody not know what is the GMT? Going once, going twice. Okay. So you can see that this is essentially GMT and this is California time. So once we convert to instant, we have time zones. How do I have it? Oh, time zone. Get we can get, you know, available IDs. And actually, instead of putting in here, I'm going to put it as a string array, because that's what this function yields. You can see it says string array get available IDs. And I'm getting that by just putting the cursor over the function and pressing the Alt key. And I get that signature like that. Okay, so I'm going to put TZs. So I can do for string A in time zones. I can now print all the time zones available. So we know that George is from Italy. And Italy, let's see, I think it's Central European time, right? Oh, Europe, there it is. Europe and it's actually based on cities. That's why Italy was not showing up. So we're gonna try to get the time for Rome. George, is Rome? Oh no, you said that Milan, right?
Yeah, but I think the time zone always just shows the
Rome.
capital.
Yeah.
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 So anyway, we're gonna see what time it is at George's house, and we're gonna see if it's okay for us to call their family and say hi right now. So we're gonna put time zone TZ equals time zone dot get time zone, and we can put the text that we use from here. And now if we do this time zone, let's see if there's a way for us to convert from time zone to is it to zone ID? Was it to zone ID? Let me just check my super reference. No, local daytime of instant, and then you put the time zone. Yes, okay. There's multiple ways of doing this. Time zone, local time is the object, essentially like putting it back in date terms. Italian time. Date is for the local. Local time is for whatever local time on a remote situation. So Italian time, we're gonna put local date time. See, sometimes Java has overcomplicated certain things, but local date time dot of time of instant, and we're gonna pass that instant object that we have now for the time zone that we're looking for. And now we're gonna find out if it's okay for George to call home by, why is it complaining here? Zone ID. And now we know that it is 6 a.m. in Italy. Let's confirm. 6 a.m. 6:03. Well, the slight difference in the minutes, but 6:02, 6:03 a.m. So that's how we can convert from daytime from one time zone to another. Any questions, comments, or most importantly, numbers about time zones? Sweet. Okay. All right. So everybody's on the same time zone. Let me on the same time zone. Since this is on the slides, I'm not gonna stop here to let you guys copy. But what I'm going to do is that I'm gonna let you guys then continue with the class exercise. So what I would like to do is I would like to give you 20 minutes for you guys to tell me to give me the code that tells us the countdown to 10 p.m. Essentially, I'm going to delete this thing here, and I want the official countdown to 10 p.m. We're going to do 20 minutes as of 9:04. So at 9:24, we finish. So from now to every time that I run it, it just has to tell me how many, let's make it a little bit more specific, how many minutes to 10 p.m. Using all the tools that we have been using, calendar, date, etc. The date parser. I'd like you guys to try this exercise and ask as many questions as possible. Okay. Okie doke. Who was able to get something done? From the read, I would say from the facial expressions and stuff, I would say, Josh, did you get something done? You're muted.
Not really.
Oh, okay. I totally read it wrong. I got the impression from that you were looking all like secure and stuff, so I read it wrong. Brandon, what about you?
Not quite. Didn't get super far, but yeah.
George, were you able to get something? Oh, he's connecting to audio. Well, let's see. In the meantime, Leon, do you have something? Okay, so maybe help me understand, everybody. What part were you guys stopped by?
I was kind of stuck on just like how to set the time to, or like, I guess grab 10 p.m. from each day.
There's two ways
So-
of doing it. Two ways that we revisited, right? So we can create a calendar. Am I still sharing? Yes, I'm still sharing. Calendar C equals calendar dot get instance, right?
Yes.
And C, we can set, we know that by not specifying the date, it's right now, right? So
Okay. Yeah.
calendar dot hour, then we set up to 22 hours. Then we can do the minute to 00.
Oh, okay.
Oh. And
Okay.
now I can do C dot get time. And that is setting it up. Doesn't matter how often we run it,
It's always gonna be.
it's always gonna be 10 p.m. You know, the seconds might be off, but maybe let's set up also the seconds. So now if we run it, now we have April 20th, 10 p.m.
Yeah, I was trying to use the set method, but I didn't get it right.
And that's possibly the fastest way to do it so that every day it works, right? Because if we did it, we could also do the date format. df equals simple date format. And then we can do something like actually we can do something like HHMM. And we can do df parse 2200. Let's even put the seconds.
Yeah.
And date parse equals that. Oh, equals new simple date format. So this is another way of, and just to
Wait, sorry, Juan, where did you say that the date? Because it doesn't look like you're passing the calendar object a date object, right?
yeah, it's initialized by default. Same with the date object. If you don't initialize, if you don't tell it when, it initialized by default of now, today.
Okay, so when you say get instance, it's automatically just setting like the date object.
Yeah, yeah.
Okay,
Now
I see.
here it's interesting. If we just pass the date, like we're getting 1970. So what I'm gonna have to do then is put the full time, which is gonna be 8/18/2021, and then oh no, sorry, that's what I gotta put it down here. And then here we're gonna put ED, comma, YYYY space. And now we have in two different ways how to get 10 p.m. Oh, on parsable. Oh, MMM.
Oh.
Now, December 27. April 18. Oh. Let's see if that was it. Or if it's, I think it's 1, 2, 3, 4. I think it's lowercase
Yeah.
y for year. There you go. So now we have two ways of getting 10 p.m. Let's go right now for the calendar because that one was the easiest one. So we know that we can then now say date now equals new date, and that gives us the current time, right?
Yep.
And what we gotta do is then now do a difference between now and the destination. So if we do long long if c dot get time in milliseconds minus now dot get time. We're both subtracting milliseconds.
Yep.
Now we can see how many, the difference of both in milliseconds is going to be. Actually, let's divide it by 1,000 to bring it back to seconds, and divided by 60.0. In both cases, we're gonna add the 0.0 to force it to be float. And this is gonna be the difference in minutes. Oh, wait a minute. What did I do here that was wrong? Let me just now let me just debug it by printing both.
You have to do.
I just want to see both dates printed. The calendar has a date of tomorrow. I have no clue why. Let's see. It's probably because it's both in the same time zone. So theoretically, hour 22. Set, oh, maybe it's 10 p.m. Yeah, I was adding 22 hours. Yeah, now it's correct. Okay, yeah, so it was one difference of a day. See, now it's 26 minutes. So basically I can say something like there are, and now I can get and let me delete the garbage here. Garbage, well, all the extra stuff that we don't need, things that we did not use. You can tell that we didn't use them because they become dull on the colors. And then this guy becomes dull on the colors. So now let's run the class. And now we have 25.16 minutes remaining.
Juan, why is when you change it from 22 to 10, why did you do that? Wouldn't
Yeah, well, should it?
Yeah, okay, so the thing is that I was essentially adding 22 hours to the hour, to the as an hour, like, so if I go back to 22 and just print it, you're gonna see how rather than 10 p.m. is picking up essentially like 22 hours from now. As opposed, so by setting 10, when I guess that when it exceeds, we should actually see what, but when it exceeds probably like the format, I think that there's like a AM, PM, and then we can do calendar dot PM like that. And that way we can force it, to be, let me just print the calendar so that way. If we want to set up like the AM or in the PM, like, let's now change it to AM. So it's 10 in the morning. And now it is 10 a.m.
So when you said 22 hours, it doesn't know that that's PM.
Yeah, no, it won't know. It's just essentially like relooping things, but increasing the date. So it's essentially like, okay, well, it's yeah.
So you said to 22, it will add 22 hours?
No, it's not adding. Like, let's go for like 13 hours, which technically, like, one is like midnight, is essentially putting it tomorrow at 1 a.m.
Oh, because we're already past 1.
Yeah,
So
but
it's
if we
gonna set
had
it to the
done
next.
12,
Yeah.
it will respect it to being,
12 a.m.
yeah, midnight.
Oh, okay. Okay.
So it essentially, yeah, in that case, when it's more than that, but if it's
Yeah.
if it is less than 12, it will set
Mhm.
up that time. Otherwise, it will add it because it's just considering it, see now 23 hours on Monday. Anyway, this is at the end of the day a very simple algorithm where we are just setting this thing. And yeah. Any questions? Okay. So homework. This is actually like the Third Street Promenade rates. So what I would like you guys to do is to write a program that allows you to calculate, given these rules. I want something that will tell me, if I put 4 hours and 10 minutes or 5 hours or whatever time I put, it will tell me how much it's calculated, how much I should pay, given my in and out times. That's a problem that you guys have probably solved in your head, that, like, oh, I have to pay this much for parking, yada, yada. Or if you're verifying that they didn't overcharge you, it's something that you have solved this problem in the past, I'm pretty sure. So basically, I want that algorithm that tells us, given those rules, how much somebody would pay. Okay, so let's do one last round of numbers before then I go into one-on-ones with people. So let's do last round of numbers, of understanding of all the concepts behind the dates and times. Okay, so there's some 8s. For all the 8s or anybody that it's below 9, is it a situation? Is there anybody without a situation of wanting to review the recording?
I think it's just like knowing which function gets what, like when to use like a calendar object or
I guess it's practice.
Date.
Yeah.
Yeah, I think, yeah.
Yeah.
for me, I guess.
Okay. Anybody else?
Yeah, I agree with that completely.
Yeah, it's a matter of practice. So that's why, the homework should actually get you there.
Yeah, I think the homework would be.
Yeah.
Okay.
Yeah, I was
George already said that he
still
needs-
trying to figure out the.
I'm sorry?
I was still doing the date and time calculation things.
This one?
Yeah. Maybe I can ask you in the later one by one session.
Yeah. Actually, so anyway, then let me then, whoever then is okay with what you guys have reviewed and you feel confident that re-reviewing them will solidify, then class is missed. I'll see you next week. For those of you that want to stay here for a one-on-one, let's then do that.